grupta toplantı açtık.
Öyle mi? Bir yerlerde program var ya. Nerede açtın?
NLP'de açtık.
Attendance. Okay. So last time, let's start from the beginning. This is what we said. In C, we had call by value and call by value. That's it. We didn't have anything else. For the call by value, call by reference, since we didn't have the choice, we did the simulated call by reference. Okay. At the beginning, they usually don't talk about the simulation part, but that's the idea. Okay. So that's the simulated call by reference, the C way of doing things. That is taking a pointer and over the pointer doing something, and in effect it looks like it is call by reference. In C++, we have real call by reference, and we talked about it, and we gave an example. Okay, we gave an example. This one, and we said that in fact this is in effect the same as writing the same function using the pointers. Okay, so I think we'd stop at this point, and after the class I realized that people are asking many questions through the chat. I am not reading the chat. I cannot read the chat. If you write something to the chat part of the Teams window, your question will not get answered. Okay, you have your microphone, just speak up. So another reminder. So let's continue from this point. If you have any questions from yesterday? Any questions from yesterday? You are sitting too close. Okay. Leave a space between you, between your class here, and you are sitting too close to. Leave an empty space. Leave an empty space. Okay. Even though you are the same person, yeah, well, you need to. Okay, good. So, any questions? Yes.
Actually, I asked that yesterday through the chat box. Is integer ampersand is a meaningful thing on their own? Like, can I declare a variable integer ampersand x?
Well, yeah, well, we are going to talk about it, but that's a good question. Question is, if I think the question comes from here, okay? When I do this integer star I1, it means that the type of I1 is an integer pointer, right? That's I think what's your name?
Abdullah.
Abdullah is asking, okay? I mean, if this means that I1 is an integer, is it the same thing as this? I mean, what is the type of variable 1? I mean, when I say integer ampersand, does that mean something? Can I write? I mean, it's same as, I mean, when you do PTR, I know that is an integer PTR. Can I do something? I reference IR. Yes, you could, but when you are doing this, you need to initialize it with something. Okay, let's say you need to initialize with an integer like this. Okay, let's say you have an integer I. When you do something like this, IR is an integer reference, but you need to initialize it with something. Because after that point, when you modify IR with something, okay, I will change. I is referring to, okay, IR is a reference to I. Whatever you do with IR will affect I. So, in a way, I and IR are two different names for the same integer. Okay, so it becomes a reference. So that's why when you make a call to this get numbers function, okay, when you make a call to this get numbers function, for example, here, this input 1 becomes a reference to first noun, input 2 becomes a reference to second noun. Again, variable 1 becomes a reference to first noun, and variable 2 becomes a reference to second noun. Okay, so this doesn't make much sense in this case, because I mean, instead of modifying IR, why don't I modify the I itself? So yeah, that's true. Usually we don't use it this much. Okay, the references are used very commonly, very popularly when you are passing parameters. Okay. Any questions? Good. But we'll talk about it later. And the nice thing is, other than that, we will have functions like these. A function will take an integer and it will return a reference. And that will be very powerful for some cases. What kind of cases? If you do that, it would be possible to say things like F2 guess the value of 13. Okay, because it's returning a reference. So for now, just know the references for call by reference only, but there are many other uses of references. Okay, in fact, this is the reason why they have introduced these references for C++. Okay, so that I can write this kind of stuff. Okay, nobody writes this kind of crazy stuff. It does not readable, nothing else. But if I like to overload this operator, okay, I need to return a reference from this. Remember the operator, right? It takes something, okay, one or two parameters, and it returns something. It should return a reference so that I can do this assignment. Good. Okay, any other questions? Let me move on then if there are no questions. Okay, so we looked at this example, and what's going on actually, as I said before, what is going on? I mean, in assembly there are no call by references, right? You know assembly, right? A little bit. So you looked at it. There are no call by reference function calls or the procedure calls. Everything is done by call by value, okay, or some other stuff. So what is going on in reference in assembly is you are sending a pointer hidden, okay, and the compiler is handling all those complications like sending the pointer, and whenever you refer to that variable, it just takes the reference and etc. Okay, so that's what's going on. That's what's going on. So don't think that calling a function with a reference doesn't have any copying cost. Of course, it has a copying cost, but its copying cost is just as simple as copying a pointer. Mm-hmm. Instead of copying the whole data structure, you are just copying the pointer of it. That's it. Okay. So that's why we say that sending an integer with a reference is not any cheaper than sending the integer itself. But sending the whole array, of course, there is a difference. Okay, good. Make this experiment using your what do we call it? Compiler Explorer. Where is my compiler? Okay, here is my compiler Explorer. I was testing some stuff and try to see. Okay, I am going to make this. I hope I can. Okay, this is good. So I use what did I use? An ARM compiler so that the assembly is cheaper. I have a k. I am sending the address of k to this function, and this num holds the address of this k. And let's do this. Let's try to assign a value 7, which is my favorite integer. And I guess that's it. Let's not make this complicated and return just 2. Let's see what kind of things we get. Okay. So this one says that the stack pointer minus 5. You know how this works, right? We are going to talk about this when we talk about the stacks and everything. This is your stack. When you make a function call, let's say f1, 2, 3, okay, the parameters are passed to this push to the stack, and in this function definition, if I have 2 integers, and if I have local variables like integer k, the place for k would be at the top of the stack. So whatever you have as local, or the parameters are pushed onto this stack, when I make other function calls, this stack grows upwards. Okay, it goes upwards, and there is usually a stack pointer, sp, that points to the top of the stack. It knows where it is. So this is what's going on here too. So stack pointer minus 4 means that I think I am going to, yeah. So no, it just stores the stack. Let's start from this line number 3, which is 6, 7, and 8. It says that take minus 8 from the top of the stack pointer and put 7 to R2 and store it where that R3 is pointing to. You know what this line is? Line 8. Store the value of R2 to the position where R3 is pointing to, and I make this loading of stack position to R3. Okay, that's what I did. So instead of doing that, let me just change it to num and that. Okay. Of course, I will get an error message here. Get rid of it. Okay. So this 6 and 7 became a little bit just one line of code less, right? So I moved 7 to R3, and I am putting exactly where this FP minus 8, that place, that's the position of this parameter. Okay. Instead of saying that follow this pointer and do that. So what I'm trying to say is that, okay, sending an integer and sending the pointer of it, it doesn't make any difference. I mean, it is using the same stack space. Okay. The only difference is whenever you are using that dereferencing that pointer, you have to follow the same steps in your assembly. And if I did the same thing with the references, let me do the reference, and somebody watch it. Somebody watch this. As soon as I hit this button, see, it became 3 lines again. It is doing exactly the same thing as the pointers. There is no difference between them in terms of assembly. So the references are for us only. Whatever is happening under the hood is almost the same with the pointers. So cost of sending a pointer and cost of sending a reference to a function is the same. And the performance-wise, using a pointer and using a reference is the same in terms of assembly. Okay? So be honest, how many people did play with this compiler explorer so far? 1, 2, 3. I have 4 honest people and maybe some shy people who don't. Okay, that's not, I don't know what's happening. I mean, the things that I am telling you doesn't make any sense. I promise you, you won't have any time before your midterm exam to play with this tool. Okay, there will be enough material for you to study. So if you are waiting for your midterm exam time, that's not a good idea. Okay, play with the stuff. Okay, try to see what's going on. Try to see how the for loop works or the while loop works, or what's going on with the cout stuff or the references and etc. And if you don't understand the assembly, just change the compiler. I mean, ARM is a very simple CPU, okay, and choose the older CPUs. I think there are CPUs of the 80s or 70s maybe. I think I saw Z80 somewhere, or the early Intel CPUs. They are simple enough for you to understand. Usually these RISC stuff is 32-bit RISC stuff. Yeah, they are simple enough. Just adding, storing, etc. And there is a stack pointer. Okay, there is the stack pointer. So this one is simple enough that it couldn't have the same instruction to do assigning a value to something, I guess. So it has to add one more. Usually the RISC structures are simpler to understand because RISC means reduced instruction set. The instructions are simpler. When the instructions are simpler, it is cheap to build that CPU, and it runs faster for some reason. Okay, let's go back. So call by reference details. Reference means pointer actually. Under the hood, pointers are working, but you are not seeing it. Okay, but you are not seeing it. So there is less chance to make a mistake, for example, forgetting a dead reference or sending the address. Okay, so somebody yesterday said that what happened if we made that parameter constant. So it's a constant integer reference, parameter 1 and parameter 2. Okay, parameter 1 and parameter 2. What does that mean? Well, you could do this. You are sending a reference, but it's a constant reference. So this function is not allowed to change those parameters at all. Even though it is receiving a reference, there is no way that this function can modify those arguments. Okay. Maybe I should minimize this that way. Why can't I see? Okay, here I'm seeing it. Okay. So sometimes we prefer this one because when you do this for the large data structures, there is no copying. Okay, only the reference is sent, which is a pointer. And if you don't want your argument to be changed by the function, you make it constant. Okay, this is a very commonly used technique to send your data in C++ to your functions. Okay, instead of doing call by value, what is the nice thing about the call by value? Your function cannot change the arguments, right? Because there is a copy made. Whatever you change, whatever you change, it will be that change will be made on the copy of that argument. Now we are saying that I am going to send you two arguments. I am going to send you by reference, but you are not allowed to change them. So there is no copying and there is no changes. So if this is what you want, then use it. Okay. So you are using the best of both worlds. No copying and no changes. Okay, both fast and secure. Well, you might say that you told us that it doesn't matter if it's integer or integer reference, their performance are the same. Yeah, that's true. This is just an example. But instead of an integer, let's say I have a vector of size 1000, then in that case, sending a vector to a function probably is best if you do it with a constant reference. So unless you want to change it. If you don't want to change it, let's say I have a function, let's say its name is print vector. It will take a vector of integers. Okay, it will take a vector of integers and its name is v. If you do it this way, it will be called by value. The whole vector will be copied, But if you make this reference, the vector will not be copied. But now there is the danger of this print vector changing your v. So what do I do? Just put a const at the beginning. So there is no way that this print vec can change this vector. Okay. So I have a question for you. If I don't write this, what did I say? There is a danger of this print vector is changing the v, right? So why is it dangerous? I mean, I am writing this function myself, right? If I don't change anything on v, then I should be safe, right? Why I would say there is a danger of changing stuff? Why is it dangerous? I am writing the code myself. I mean, I am not crazy, right? Well, I mean, if I don't change anything in print vec, if I don't change any element of this vector v in print vec, then I should be safe. I mean, why am I afraid of? Yes?
And we could forget that we are sending a reference midway, writing the function.
Anybody heard it? Anybody heard it from there? No, I don't think that. For some reason, I cannot make you speak up. He says, what's your name?
Alihan.
Alihan says that maybe, I mean, we are humans, we will make mistakes. We might forget that this v is not supposed to change, and I make a change, or maybe some copy pasted some code from somewhere else, and that code is changing stuff. Or maybe I mean, let's look at this code actually. I did something, and I am sending this v to a function f. And I forgot that f is making modifications on this v, right? So the compiler will not help me in this case. But if I put a constant here, compiler will definitely tell me that you promised that you are not going to change it, now you are changing it. Okay? Good. So this is one way of, again, using the references with the const modifier. Okay, let me move on. Parameters and arguments, we talked about this before actually. Okay, we talked about this before. We said that, let me go back again to this one. I mean, as I said before, people use them interchangeably, but just to make sure, these are formal parameters because these are in the definition of the function, but these are arguments. First name is an argument. This is a parameter. Okay. So I myself do this mistake too. I always call them parameters. I call these parameters, but these are arguments actually. Okay. Arguments, parameters. Okay. So just a reminder again. Using the correct terminology is important. Okay. I think somebody asked this question before. What's a mixed parameter list? Mixed parameter list is very simple. We say that if you have a function mixed call, this function can take integers, doubles of course, but it can take integer references, call by value integers, double references, right? So this is as simple as this. So I can call this function with with this line here. Well, this doesn't look like an A, but it's an A actually. Let me write it better. So this is an A variable, and this is another variable D. A is an integer, D is a double, okay? And this is what happens, okay? So the reference of A is passed, value of 7 is passed to parameter 2, and the reference of double D is passed to parameter 3. Okay, this is fine, but this is not fine. This line is not fine. Okay, this line says that pass 1, 2, 3. Well, 2 is okay because you call by value, but 1 is bad. Why? Because you cannot take the address of a constant, literal constant. And 3, you cannot have, well, two things wrong with this one. It needs a double reference, okay? you are sending an integer. That's one thing bad. The second thing, let's fix that part, okay? Let's fix that part. Let's make it 3.0. Now it doesn't fix the whole problem. The problem is you cannot take a reference to a constant double, literal constant double, unless it's a constant reference. In that case, you should be fine. Okay. Yes.
If one is integer and the other one is integer pointer, will it be again mixed type?
If one is integer and the second one is what?
Integer pointer. One data type and its pointer actually.
You mean instead of sending an integer, you are sending an integer pointer?
Yeah.
In C it is okay because integers and pointers are almost the same thing in C. In C++, no, I don't think that's going to compile. At least you are going to get a compiler error. If you like to do that kind of C stuff, yes, you just force it by using typecasting. If you typecast it, it will not object it. I mean, typecasting means that this is what I want. I am doing this on purpose. You could, but usually in C++, we don't play with those kind of stuff. Okay, good. No questions. I am moving on then. Okay. As before, definitely choose formal parameter names properly, meaningful names, etc. So parameter 1, parameter 2, parameter 3 are not good parameter names. I mean, if you have to choose the names like that, 1, 2, 3, 4, 5 the parameters, then that means that there is not much meaning to your parameter. So if you cannot name it in English or in Turkish, you don't know what you are doing actually. So go back and think about what you are doing. Okay, any questions up to now? No. Okay, let me start this new topic, overloading. Overloading, the name overloading might be new for you, but you have been using overloading since the first day of your C language class. What did we say? I think we said this before. You use this plus operator to add two integers. Maybe, yeah, to add two integers. Okay, and you use the plus operator to add two doubles. Okay, the meaning of this operator and the meaning of this operator in terms of assembly produced is very, very different. Okay, they are very, very different. They are two different operators actually. Okay, for the computer they are as different as like the multiplication and addition. Okay, two different operators. I mean, just produce the assembly code and see what kind of instructions are produced for the for this plus and for this plus. Of course, not newer types of processors, but old type of processors. They are very, very different. But I was using the same operator plus. So this operator plus is overloaded in C. Okay, it is overloaded in C. In C++, we say that if the core of the language is using overloaded operators, why don't we use the same idea for any kind of functions, not just for operators, for any kind of function. So I will let you use the same function name for different functions. Okay, you might have more than one function f doing the different things. So that's the name of the overloading. You are giving a new meaning. You are giving a new meaning to a function name. Okay. For that, let me make a definition. It's called signature. Okay. In C or C++, every function has a signature. Okay. And you cannot have two functions having the same signature. Every function should have a different signature. Okay. Every function should have a different signature. In C, again, there is a signature, but the definition of signature is so simple. In C, the definition of signature is this. Okay, just the name. C signature is this. The name of the function is the signature. That's why you cannot have two functions like this, okay, although they are taking two different parameter sets. One takes a simple integer, the other one takes two integers. These two cannot coexist in C programming language, because C signature says that their names are the same, that's it. Okay, their signatures are the same. C++ says that signature is not just a name. C++ says that signature is the name plus the parameter that it takes plus the types of the parameters and the number of the parameters. As long as one of them is different, then for C++ everything is fine. For example, this one, and this one, let me write them in different colors. I need more colors. 1, 2, and 3. These three functions, f, they can coexist in C++. They are overloaded. Why they can exist at the same time? Because their parameters lists are different. Okay, their signatures are different. Okay. So what is the definition of signature in C++? Name along with the parameter list, including the parameter types, parameter numbers, and their order. Okay, their order. The last one, the signature of the last one and the signature of the second one, the fourth one is a bad one. Okay, signature of the fourth one and signature of the second one is the same. Why? Can anybody tell me? The return types are different?
Because the parameters are the same.
Their parameters and name are the same, but you see the return type is different. But I didn't say that the return type is included in the signature, right? Return type is not in the signature. Okay, return type is not in the signature. So 2 and 4 have the same signature, so they cannot coexist in the same program. Okay, they cannot coexist in the same program. Okay, good. So that's the definition of signature, and overloading comes from here. You may have the same function name for different functions as long as the signatures are different. Since the definition of signature is very simple in C simply say that signature is the same as the name. You cannot have two functions with the same name. So why are we doing this again? I mean, this is just a generalization. If I use plus for different plus operator for different purposes, okay, at the same time, why can't I do the same thing with functions that will make my programs more readable? For example, let's look at these two functions. The function name is average, very nice name. So what do you expect from the average function? It will take two parameters, it will average them out and return it. Okay, how about this one, average? Okay, how about this one, average? Again, the name is average. It will take three parameters and average them out and return it. These two can coexist at the same time in the same program without any problems. Compiler will know it. Okay, whenever I make a call to average with two parameters, it will call this one. With three parameters, it will call this one. With just one parameter, if I make a call to an average, I will get a compiler error. It will say that this signature doesn't match anybody. Okay. Could you turn off your computer, the one back there? No, you are not. You are not watching me. You are doing something else. Are you watching this? Okay. Just looking at the call type, you can determine the signature and make this signature. Okay, make the signature work for your purposes. I mean, signatures and the overloading is not there to confuse you. Okay, it is not there to confuse you. It is there to make your program clearer. What is the C way of doing this? How did we do this in C? We usually say that average 2, right? Give a name to this average because it takes two parameters, and maybe do this average 3, right? You know this arctangent function in C, arctangent? there is one function that takes a double, and there is another arctangent that takes two doubles. So C makes it arctangent and arctangent 2. Okay, but in C++, I don't have to. Okay, both of them could be arctangent. Okay, so overloading is this, but sometimes, okay, we need to be careful when we are doing this overloading, because we are not doing this kind of stuff to hurt ourselves. Okay, don't use overloading. For example, this is not a very good way of overloading stuff. The function f is not a very meaningful, although I keep using f just to keep things simple, but for the real programs, f is not a very good function name. Okay, because it doesn't explain anything, function f. What is the point of overloading this function f with string, integer, double, and etc.? Although you can do it, yes, they have different signatures, it doesn't make sense, okay? Because the function name f doesn't make any sense. F to me means that it's a generic function, okay? So if you need to do this kind of stuff, then I would prefer f, g, h, etc. standard function names, mathematical functions. Overloading them doesn't make any sense, okay? I mean, the fact that you can do it doesn't mean that you should do it, okay? You should always ask, does it make any sense? So use overloading in a sensible way. If it makes sense, then use it. Otherwise, don't use it. Okay, so let's try to see some problems with overloading. We will have problems like, yeah, let's say I have these. That stupid mistake. I overloaded this f with 3 overloads. One of them takes an integer double integer, and integer. I mean, I made, in this case, 2 mistakes. It's very confusing. Why are you overloading f? The same name doesn't make sense. Let's skip that part, and let's look at other parts, okay? So let's look at this one. What does f 9899 will call, okay? What does this call? Of course, this will call the third overload, right? Because these are 2 integers, okay? This will call the third overload because it is just 2 integers. How about this one? F 5.3 comma 4, it will call double an integer, right? That's what it says. How about this one? Well, I mean, double and double here. Maybe the second one, maybe the first one. So the integer doesn't mix. Maybe remember the sign function. If I send an integer to a sign function, there is an implicit conversion going on in there, right? Maybe a demote a double to an integer. I can call one of these, but should I demote this 4.3 to this one or 5.2 to this one? So first or second? I don't know, okay? So the idea is avoid such confusing overloads. Sometimes you have to do those kind of overloads. If you do that, if you write this kind of code, function calls, you will get a compiler error. Okay? You will get a compiler. Error. Okay? Sometimes, for some reason, you have to do this, but then don't make a call like that. Okay? The compiler will get confused. Okay? In C++, there is a way of specifying which one you want to call. For example, this one. This one says that I like to call this function f, but which overload? Integer and double overload. That is this one, the first overload. You are forcing the compiler to make you are making the decision for the compiler. You are saying that I am calling this overload, the first one. But again, this doesn't make much sense. If you are going to name your function which one you are going to call, why are you using overloading then, right? So don't use this. It is possible to use it, but don't use this. Do this overloading in a sensible way. Okay? Questions? Any questions? Yes? Say it
so
louder. Everybody can hear it.
for the functions printf and scanf, aren't they like they're too similar to overloading? Or they
Function
like
printf and what?
and scanf in C.
No, because their names are different. One of them is printf.
No, I mean like printf. I can. There is not an exact number of arguments I can use it.
Well, in C, maybe they didn't show you. In C, it is possible to have functions with variable length parameters, like printf. You say that, okay, this is a function, and this function can take as many parameters as it likes. The only rule is the first parameter to that function should be a string. Printf and scanf works that way. It takes a string, that's the only thing that you need to give, and after that all the parameters you are free to give actually whatever you want. But in fact in C, okay, in C, just write this code: integer main function f 1 2 a b c and character c and return 0. This will compile but not link, but it will compile. Although there are no functions named f doing this, in C it is possible, because in C if you don't define the function header, okay, C assumes that I will not do any parameter checks. Whatever the customer gives me in this code, I will take it and I will produce code for it. But it will not link it. Of course, there is no function f. And in fact, let's this is GCC, right? Let's try this. Just get rid of this main so that it wouldn't link. And a function doesn't take anything and doesn't return anything. Void. Let's make a call to this function g with 1 2 3.5 and okay, a character, and that's it. And I made a syntax error there. Compilation failed. Why does it say? It says that for more information see where is my output. This is I think C++ editor, okay. Oh, okay, this is C++ source. It is using a C, okay. Let me add a source editor, but again it's a C++ thing. How do I add a C different tree? There was a way of, what is this? Compiler. Okay, let's add a compiler. Again, I think I added a new compiler. Is that true? Okay, get rid of this one. Somebody was saying something. Oh, okay, here it is. Okay, sorry. C. I made it C. Yeah, it compiled. See? Oh, well, because it compiled because it has this one. Okay. This one compiled to, let me try to choose a earlier compiler somewhere. What did it say? Oh, okay, because I made a mistake here. Okay. So it compiled. So it is making this function called G. It doesn't know what kind of function it is calling, right? It's just pushing, okay, all those parameters or moving all those. Let me try to use a simpler assembly. ARM is good. Yeah, let's use ARM. Not 64, but 32 ARM. 32 ARM is better. ARM V8. Okay, let's use this. Oh, again, it's a 32. Older ARMs. Yeah, okay. So, but instead of pushing all the parameters to the stack, it is moving all those parameters to the registers. So it says that move, where it is, okay. move, okay, move 1 to R0, the first parameter, 2 to R1, and I think one of them is 3.5, I don't know which one it is. What is the assembly, what is the ASCII code for S? Is it 115? Is this S 115? It might be. I don't know. So my point is, okay, regarding your question, who has the question? You asked the question?
I asked.
Okay, you asked the question. Regarding your question, printf and scanf, in C these rules are very relaxed, and in fact in C you don't have to have a the header of a function to be called. Okay, you just make a function call. If you provide a function, if you provide a function header here, let's say void g and curly bracket, okay, here it is, I found it. Okay, it doesn't do anything. Now it doesn't compile. Did it compile again? Well, I think there's a switch. If you provide a function definition like this, usually, let me do this. Let me just take integer I, compiles it. Yeah, okay, it compiles it. Okay, so it says that this function is defined this way. It is supposed to take an integer. You are sending these. Now it turned on the type checking and etc. So in C there are several mechanisms like that. In C++ we don't like those mechanisms. In C++, if you are going to call a function, its prototype has to be defined before.
Pardon me, when are we going to give a break?
Say it again.
When are we going to give a break?
No, just now. Okay, let's get 10 minutes of break. 15 minutes of break, sorry. Thank you for reminding me. Let's be here around 10:35. That guy is listening to me. He didn't go by himself. He was waiting for the break. I have those kind of students, okay? I am proud of you, whoever you were. Arkadaşlar yoklama nerede ya? Şu yoklama kağıdını saklayıp durmayın ya.
Hocam burada.
Peşinden koşup duruyorum.
Hocam ben dün ismimi yazmıştım da.
Seninkiler mi?
Sen başka birisi yazmıştı. Şu anda baktım hala da duruyor ama. Ya ben kaydetmedim. Onda sıkıntı oldu.
Git oraya bak kimler değiştirmiş orayı. Oraya bakabiliyorsun. O hücreye git. Bunun tarihini bana göster de o adamı bul. Bilmiyorum, yaranız halledin.
Atayım ben imzayı hocam altına. Kendi imzamı.
Hayır, yok ki burada yer. Ya geldin, dinle biraz. Yarın da gelirsin.
Hocam sıkıntı olmaz da.
Heh.
Atsaydım.
Arkadaşlar burada durmayalım ya. Camları açıp çıkalım.
Hocam bir dakika sürecek bir şey sorabilir miyim? Ödev
Sor,
hani
dışarı.
kullanmak yasak ya. Yasak değil de.
Ne kullanmak?
Type array'i kullanmayacağız ya.
Evet.
Yani bir şekilde vektör tanımladıktan sonra ona erişmek için şunu kullanmamızda bir sakınca olur mu?
Olmaz tabii. Vektör ne istiyorsa biz derste kullandık. Onu ne yapacağız? Vektörü neyi kullandırabiliyorsa hepsini kullanacağız.
Ben de ödevle ilgili bir şey soracaktım da pointer ve kullanabiliyor muyuz? Struct acaba?
Ödedi mi?
Hı.
Hayır, yok.
Struct da mı?
Struct yok ya. Struct öğretmedim ki ben.
Ben biraz araştırdım da herhalde C'dekiyle aynıymış galiba.
Benziyor çok. Yani C++'dan öğretmedim. kavga ediyoruz gibi yani.
Gerçekten güzel. Ben yıkıyorum yanında. Farklı bir evet, o da güzel. Ödevi yapamazsınız ki. Çalışma ödesi header'lar oluyor. O Ubuntu'yu, BS'yi yükledikten sonra o Ubuntu'yu oraya aktardıktan sonra dümdüz çalışıyor. Hani print yapmak için bile 30 saniye bekliyordu. O derece. Çünkü zihnini anlayardı. Mesela iyi. Yani şu anlık sıkıntısını görmedim. İnşallah da görmem de. Tam okuyorum. Yarın başlayacağım. Yarın çünkü Perşembe okula geleceğim. Cumartesi'ye geleceğim. Sonra gidecek diye. Cumartesi, pazartesi kaldı. Söz okula gideceğim. Pazartesi gelmem. Hallederiz herhalde. Yarın bir bakayım işte. Hani evde dediniz de mesela taşın olduğu yere nokta mı koyuyor? Orada hani kriter yazıyor. Ha, o attığı şekilde tamam. Ha, öyle. Nokta falan. Yabancı geliyor. Olur olur. Ben yaparım.
Okay, overloading is always, as always, when I introduce something new to you, there is the right way to use it. If you use it in the wrong way, it will become harmful, not useful. So this is the case with the overloading. If you don't do it right, I mean, never do this. Okay, the names are bad, doesn't make any sense. These names are good. This averages. Okay, average and average, because taking the average of 2 numbers, 3 numbers, and etc. But overloading a function named f doesn't make any sense, and overloading with these parameters doesn't make any sense. Okay, And these are the rules for overloading resolution, if you like to know. First, the compiler is going to try to find exact match. Okay? Exact match. If I say f double and f string, and if I do this f1, there is no exact match, so it will try to do the second way of resolving stuff. What is compatible? I mean, can I make a double out of integer? Can I make a string out of integer? So if I do it with the promote integer to a double without losing any data, then I can do it. If that doesn't work, if there are no calls like that, maybe I can do a demotion. Lose some data, some digits with the double to integer and do it that way, okay? And if this doesn't work, then it's going to produce a compiler error. By doing these compatible match conversions, if there are more than one way to convert your data to an overloaded function, then it's going to produce another compiler error, like we have seen before. So always aim for this one, exact match. Whatever the function needs, just send that information to function, exact type. Don't try to make the compiler to make these kind of conversions for you. Okay, sometimes you need it, but this should be your first aim. Okay, the first way of doing things. Okay, overloading, something simple. I introduce one new concept, signature. Okay, in C we have, well, they never talked about the C function signatures to you, right? They didn't tell. Doesn't make much sense because, I mean, if the name is the same as the signature, why do we call it signature? And we just, I mean, what is the rule in C? In C they say that you cannot have two functions having the same name in C. That's it, right? They don't make any definitions for the signatures. But in C++, it is possible to have two functions having the same name. But what are the rules? Then they are coming up with this idea of signatures. Okay, as long as their signatures are different, okay, then you can have them. If their signatures are the same, then you cannot. Okay, what is the definition of signature for C++? The function name, the parameters, including the parameter types, the parameter numbers, and the order of the parameters are important too. But function return type is not in the signature. Okay, function return type is not in the signature. Okay. Automatic type conversion and overloading. Okay, we talked about this a little bit. Okay, usually, I mean, many people write this. I know that. Okay, I know that this function sign takes a double, but I mean, of course, this is not right, because it takes a radian. Well, ignore it, or maybe I should write it correct way. SQRT 90. Okay. So I know that it takes a double, but people keep sending integers. So how does it work? Automatically, this 90 is converted to a double, and I will send a double to it. Okay, I will send a double to it, and that's done automatically. The book says that if you use this feature, this automatic type conversion, although I don't suggest it, okay, you don't have to overload this SQRT with integers and the doubles and the floats and etc. So just write it for double. It will work for the integers, and we have been doing this with C. But my suggestion is, don't send an integer to a square root function. Send a double. Okay, just do this. If you are lazy to write these characters, these two characters, I suggest you do this, just 90 dot. That's it. Okay. So typing one character is less work than typing two characters. Okay. Good. Okay, we talked about this automatic type conversion and overloading example. I have this miles per gallon example, it takes 2 doubles. I can call this with 2 integers, 2 doubles, 1 integer, 1 double is going to work. So we already know this from C, so I'm going to skip this one. Okay. Any questions so far? I'm going to start a new topic, new C++ edition. Yes.
I don't understand the conversion. Like float is matching with which one?
Well, I mean, usually, okay, if you have a function that takes a double, the compiler knows how to convert an integer to a double, float to a double, character to a double, okay? Like the square root function, okay, in C. We can call the square root function with an integer or with a float or with a long, with a character. Doesn't matter. Compiler knows how to convert it to that double. Okay, that's what I'm saying. So there is, in this slide, there is nothing new. You already know about this from C. Okay, this slide says that use this feature of the compiler instead of overloading square root with integers, doubles, floats, characters, and etc. Don't overload it with 4 times. Just write it for the double. Compiler knows how to convert an integer to a double. That's what it says. Okay? I didn't say anything new. I didn't say anything complicated. What I am saying is that don't call square root with a character. Definitely don't do it. Okay? Although it is possible, don't do it. That's very confusing. I mean, what would you expect out of this? This. Okay. I am taking the square root of 65. Is that correct? Or maybe this is 65, right? Is this 65?
Yes.
Yeah. Okay, so it is going to be around 8 point something. I mean, the fact that it works doesn't mean that you should use it or it is okay to use it. It is not okay. Okay. So what I'm saying is that if square root takes a double, send a double. That's it. Okay. Do this. Don't do this. Okay. I tried it and it works. It's not a good explanation. Okay. I tried and it works. It's perfect. No, it is not perfect. Okay. This is not the way to write programs. Okay. Compilers are your friends to learn a language, your best helpers. But compilers not all the time will lead you to the correct solution, okay? You should not always trust your friend's mind for you, okay? You should sometimes take the initiative and you say, okay, what you are doing is not correct. Okay, we are not going to do it that way. Okay, good. Another questions? Okay, good. Yeah?
In previous lecture, you said that we can specify which version of a function, overloaded function we want to use. Can we do the same thing with the operators, like plus?
Like plus, okay. So can we do the same thing? Yes. I mean, do you mean can I overload the plus operator?
No. Adding 3 and 4, but with double.
With double? What do you mean? I mean, you can already do that. I can do this. I could do this. So what is your question?
If I write double, comma double after the plus in brackets, does that work?
No. Oh, you mean, okay, you mean 2.0 plus 1.5 comma 2.1. Are you trying to use the comma operator?
I mean that.
When you say previous lecture, I thought it yesterday. Yeah. Okay. I don't know. He's asking this. Remember this one? I said that. Okay. If you like to force the compiler to use this overload, he's asking me, can I do this plus double and then what are you going to do? 2.0 and 5.1? Is that what you're saying?
They should be integers.
Are you in? I don't know. I don't know if this works. I don't know if the one that you are saying is work. Okay, just try it. But whatever you see, okay, just come back and tell us if it worked or not. Okay. But whatever you do, whatever you learn, don't use it this way. Okay. Don't use it this way. By the way, 1 plus 2 is exactly the same as there is a function named operator plus. Okay. 1, 2. This line and this line are exactly the same thing. So this operator plus, okay, it calls this function named operator plus. Its name is operator plus. So if that doesn't work, then try this operator plus double then 1 2. Okay, try that one. Okay, and we are going to see more about this when we do the operator overloading. Okay, so this kind of thinking is the right way to go. Okay, always try these kind of things that doesn't make much sense. Okay, that will teach you a lot. It's like how does the children learn from stuff? Okay, they just test it, right? Okay, you are all grown ups. You just sit here and you just listen to me, right? I cannot do the same thing with 2-3-year-olds. Why? They have to experiment stuff. They have to walk over the chairs and maybe just test the handles of those windows and shout and break stuff. And because they have to test, they have to do senseless stuff, meaningless stuff. While they are doing it, they learn stuff like, oh, maybe I shouldn't do this because this one hurts. Okay. I tried that before. That makes me bleed. Okay, it's that kind of stuff. So it's the same thing. Try this kind of stupid stuff. You are not going to hurt yourself. You are not going to hurt the compiler at all. Okay, and that will teach you a lot. I mean, you are not testing these. You are not testing these because you want to use them. You are just trying to understand if it works. While you are doing this, you will get compiler error messages, and you are going to understand why you are getting that compiler message. And then you will realize that you understand something wrong or in a different way. Okay? Always do this kind of experimentation. I am not going to teach you C++ 100%, okay? We are trying to just start something here. I mean, I am not going to teach you everything. You are going to learn it from the compiler, from the book, and from yourself. Okay? Again, as I said before, this is not a history class. By the way, I'm not trying to minimize the contributions of the history teachers and that kind of stuff. I don't know how to teach history class. I suppose you just read the book, I guess, right? I mean, because you cannot simulate stuff. You just read it, compare it, whatever. But you have to do the experimentation with your compiler and with your online tools like the Compiler Explorer. Okay, good. If there are no other questions, then I will move on. But this one says that my network is going bad. Do you guys can hear me, online people?
Yes. Yeah. Yes, hocam. We can hear you, but if you close your camera, it will be better for us.
Okay, I'm turning off my camera. Maybe that will help you. Okay.
Okay.
But it looks like my network is back to normal again because I'm not getting the message. Okay, let me move on. Automatic type conversion, default arguments. Okay, another new mechanism is in C++, which is related to overloading. Okay, default arguments. When you are writing a function definition, function declaration, you can do this. Okay, show volume. So this function is going to show me, print the volume of a rectangular prism. Okay, so three-dimensional object, rectangular prism. So it needs the length of a rectangular prism, that structure. Okay, it needs the width and the height. So I have a 3D structure like that. Okay, this is W, H, and length. Okay, so I give three numbers. I mean, the function is very simple. It just multiply those three numbers and it will print it on the screen. That's it, right? But look at these weird stuff, weird notation. We have never seen it. This one takes three parameters, three integers. If you provide three arguments here, if you provide three arguments, then it's going to be fine. Call by value. 2 will be copied to length, 4 will be copied to width, and 6 will be copied to height. Okay, that's it. That's one thing. But if you provide two parameters, 3 will be copied to length, 5 will be copied to width. Since you did not provide the third argument, this will be the default argument. Okay, height will be automatically by default 1. Okay, that's why they are called default argument. If you don't provide it, okay, by default, you will get a default argument to height. Okay, again, similarly, if you provide a single argument only, 7, okay, 7 will be copied here. Since you did not provide two arguments, those arguments have their default values, which is 1 and 1. So it looks like I have overloaded this show volume function with 3 overloads. One overload will take one parameter, 2 parameters, and 3 parameters. In fact, I did not. There is a single function, but using this default arguments mechanism of C++, I can make these kind of calls. This is very useful, especially if you have lots of parameters to a function. Some functions takes maybe 7, 8 parameters, and I am not changing most of the time. I am calling these functions with the same parameter set. Okay, so I don't have to repeat those arguments over and over again. I just default them, and that's it. Okay, that would be it. Let's see the example. Here is an example. Okay, let me get rid of, because these are not important. Okay, so show volume. This is my function declaration. It takes length, width, and the height. Two parameters, 2 arguments are defaulted to 1. So both of them, 3 of them will work. No problem. You should include this in the function declaration. When you are implementing this function, I am not repeating those values, see? Okay, this is the function implementation. And function implementation, look at the function implementation. It just uses the length, width, and the height like a regular function parameter. That's it. Because this function doesn't actually know, I mean, if you look at this 16 to 21, the function body doesn't actually know about the default arguments. It only says that, okay, I have these parameters and I'm going to print them on the screen. That's it. Okay, the thing happens while you are making this function call. When you say, okay, line 12, show volume 4 will be copied to length. This one and this one will be assigned the values of 1 and 1, okay, or copied values 1 and 1, and this function is called after that. The function doesn't know that the function body doesn't know that it is getting those parameters by the default arguments or the real arguments. Yes, there is a question from the online audience.
Yeah, in this case, what if we want to push the length and height, but we want to use the default value of the width? How we can?
You can't. No, you can't. Default value. The question is this: I like to make this function call line 11. I like 4 to be copied to length. I like 6 to be copied to height, and I like width to be 1. No, it will not happen. If you are using the default arguments, Those arguments assignments will be done from right to left. Okay. If there is a missing number, missing parameter, so that must be the last one. If there are two missing parameters, that must be last one. Okay. It goes that way. So that means that the parameters that you don't change much should be your last parameters in your functions. Design your functions that way. If you keep changing a parameter all the time, don't default it and use it as the first one. Okay, so that was a good question.
Okay, hocam.
Any other questions? So we use this a lot actually. As I said, this is related to overloading. Why? Because I mean this looks like an overloading, but it is not overloading, of course. And the other dangerous thing is this: void show volume. I am trying to overload it with a single integer I. You are in trouble here. Why? Because line 12, I don't know which one to call. Line 3.5, sorry. Line 3.5 with a single integer, or line 4, one integer, two defaulted arguments. I don't know, okay? So if you write this one, line 12 will produce a compiler error, line 12, okay? If you don't make that call for line 12, you're fine. But line 12 is going to make a problem now. So you should be careful again. Like always, anything new, powerful looks nice, but if you don't use it, you will be in trouble. In this case, you will be in trouble, but the compiler will help you. Compiler will give you an error message. Sometimes the worst trouble is you don't get any messages from the compilers. Good?
Hocam,
yes?
So, the default arguments, default parameters are not evaluated in function signature, right?
They are not default parameters. They are default arguments, right? Yes, they are not included in the function signature. The function signature of the show volume is, okay, name show volume, 3 parameters, they are all integers. That's it. That's a good question, okay? It doesn't, being default doesn't change the signature, okay? Signature is the same.
Thank you, sir.
Okay, but related to that one, maybe it is not related, but I just, since I am the teacher here, I can talk about anything I like. Integer I and const integer I are two different functions. Their signatures are different. Okay, this makes sense. This makes sense when you do this kind of stuff. Okay, these are ampersands. You know why my ampersands, right? Anything. If I try, I can do it better, but yeah, for now, this is the best I can do. Okay. Yes.
Can user decide what should be the default argument? This, for example, before calling that function, user choose one minimum number. For example, instead of 1, we are asking the user what should be the default argument, and it says, for example, 2. And after that, we are passing that as a default argument. This is possible?
You have to make your decision while you are writing this code. Okay, line 4, you write it, and that's it. There is no changing of it. Because you write, I mean, even it doesn't let you repeat these numbers 1 and 1 here, okay? If you repeat it, you will get a compiler error, because I have already told the compiler that default arguments are these. So you are saying that dynamically, can I change my, no, it is not. It's not a good idea, and the compiler doesn't allow that. Okay, good. So we looked at this example, and I think that's about it about the default arguments. What else can I tell you? I think that's basically it about the default arguments and the overloading. And in your homeworks, you can use them. Somebody asked me, can I use references in my homeworks? Of course you could. We talked about it in your homework number 1. If you like to use default arguments, yes, you could. Anything we talked about in the class can be freely used in your homeworks. Okay, let's talk about this testing and debugging stuff. Okay, so when you first, as soon as you started writing your first C program, definitely after you sorted out your compiler problems, okay, you fix your compiler errors, then you run into logical errors, right? I mean, I am comparing two values, and the result doesn't come back right, and etc. What would you do to debug your program? Usually, we put lots of printf or cout statements, right? Printf or cout statements. So you have, let's say, 100 lines of code. After every function call, you print them out to see the parameters are right and etc. Okay, so this is what you did, right? Lots of printfs everywhere, if the things are going right. What is the problem with that? Putting lots of printfs everywhere? To see if the parameters are right or to see your intermediate calculations are correct. What is the problem with lots of printfs? Yes?
Exhausting. It's like it's hard to put a cout in every.
Yeah, writing them takes time, yeah, but after you write them and they are helpful, you figured out the problem, then after that, you end up having lots of printouts in your program. You have to go back and you have to erase them, right? But then realize that after that, you realize that you have another error. So what would you do? You write them back again, okay, you test it, and this goes on and on and on, but you don't want to keep your printfs in your program because that's not what your program is supposed to do, printing lots of stuff. But printing lots of stuff is useful for debugging, and so what is the solution? Usually we do this, right? Let's say I have a function like that. I take two parameters, an integer I and string s, and I like to print these two values at the beginning of the function to see if I am getting the correct values, right? So there is a cout statement here, but I don't want to keep this all the time. So what I do is say that if ndebug is not defined, ndebug means no debug, okay? If not def, if ndebug is not defined, then print them out. Okay, good. And at the end, I do some calculations before I returning it. I like to print this out to the screen so that this is getting okay. Let me turn off my camera again. Before I return this value of d, I like to print it on the screen so that I can see it. So of course there is the useful code here, useful code. So what is the solution here? If in my program this ndebug is defined, then this line will not be compiled and this line will not be compiled, so I won't see it. For some reason, if I like to debug my program, I turn on, I turn off this flag. I don't define it, okay? So if I don't define it, since it is not defined, then they will be printed. Okay, so this is one solution for writing lots of cout statements to debug your programs. Okay, maybe you tried this before. Did anybody try this? Did anybody try this? Did they teach you? Okay, just one technique to debug your programs. The nice thing is this. Okay, when you are when you are compiling your programs, if you compile it with G++ -d, no debug. So this defines this flag, and your compiler will not compile this line and this line. So you are not making any changes to your program. Okay, you are not making any changes to your program, and the effect that you wanna do is automatically achieved without modification your programs. Very nice way of turning on and off your debugging options. Okay. Some people do it even they go one level further. They say that debugging should be done in levels. Okay. Sometimes I like to see all the data, so maybe debug level 1, debug level 2, debug level 3, no debug 1, no debug 2, no debug 3, etc. Okay, so you could do it that way too. Okay. By the way, this no debug flag, we call it a flag. Okay, it's kind of standard. Everybody knows about it. Compiler knows about that too. You know this switch, compiler switch optimization. Okay, -O. If you make -O3, this means that do whatever optimization you can to the compiler in terms of CPU usage, memory usage, etc. This compiler automatically defines this no debug. Okay, this compiler switch -O3 defines this debug automatically. Say that no debugging in the optimized code. Okay, so and debug is something known by everybody, including the compiler. Okay, good. That's one way of doing your debugging stuff. After you write your programs, you do it that way. Okay. What else? Lots of cout scene. Okay. There are of course compiler debuggers. I think Ilhan sent you a message about how to install Eclipse IDE, Integrated Development Environment. Eclipse comes with its own debugger. Definitely learn how to use those debuggers. How many of you used the debugger before? Okay, good enough. Did they teach you how to use it, or you learned it?
We learned it.
You learned it yourself? Yeah. Well, I mean, the debuggers are very useful in terms of debugging your programs or learning the language itself, because every time you hit the next button in your debugger, you can see all of your variables, what has changed, what did the last line do, and etc. How the control flows in your program after each statement, those are all important. So learn how to use the debuggers. They are very, very important. And then we have this assert macro. Assert macro, but as the name implies, it's a macro. What's a macro? Maybe we should talk about yes, what's a macro?
Text replacement.
What statement?
Text replacement preprocessor.
Well, yeah, well, that's a macro actually. Yeah, this defined macro is a macro. Okay. Define size 10. Yeah, it's a macro. That's true. But very simple macro. But then we have other types of macros. For example, define S, okay, QRT X. Macros can take parameters like this. Okay. And I will define it by X times X. So wherever you see SQRT with a parameter in your code will be replaced by this. Okay, will be replaced by this. For example, in my code, let's say in my main code, okay, I can say A gets the value of SQRT5. The compiler will get this, okay? Compiler will get this. It will take this one, sorry, preprocessor. Preprocessor will get this. It will replace this SQRT5 with 5 times 5. Okay? So this is not a function call. This is not an operator call. This is a macro. Simple macro, a little bit more complicated macro. But this macro is very dangerous, and I didn't do it. I didn't write it correctly. It's very dangerous. Let's look at this one. Why? So, how does the compiler treat this? It will convert it to, sorry, preprocessors. I keep saying the wrong thing. it will convert it to A gets the value of 5 times 5, right? Which is correct, no problem. But how about this? B gets the value of SQRT x plus 1. So this will be converted to what? You tell me. B gets the value of x plus 1 times x plus 1. You see the danger? That's bad, right? So how would you solve this? How would you solve this? Did you see the problem? Put parentheses, right? I mean, put parentheses here and there, right? So this should show it. It's going to make this replacement like that, and it will solve it, but there is another problem. What is the problem when you say B gets the, okay, B gets the value of let me make this okay minus, and this is not SQRT but this is diff. Okay, B gets the value of diff A plus 5 times 2. So did you see it? So it's going to be like B gets the value of A plus 5 minus A plus 5 times 2. Did you see the problem? Multiplication is going to be done first. So how would you solve this problem? You put more parentheses. So if you do that kind of stuff, you should be fine. Again, this is not a function call. This is a pre-processor directive, and it's called a macro. And you can do many things with the macros. You can do many things with the macros. Sometimes it can be very, very useful. Sometimes it is very confusing. And assert is such a macro. Assert is such a macro. It is defined by the standard C library. It is available in C. And we are going to see it in a few minutes, but I am out of time, maybe tomorrow morning. Okay? So I will stop here. If you have any questions, I can answer. No questions? Any questions from the online audience? Online people? How many people do I have now? $59 people. Okay, not bad. Okay, good. I'll see you tomorrow morning. Some of you tomorrow morning.
İlhan kısmını anlamadım da ben.
Efendim?
Orayı anlamadım.
Niye anlamadın?
Site.
Bir dakika dur. Hangisi?
Şimdi mesela şurada bunu hani burada hata yoksa bunu mu bastıracak anlamında bu kullanıyor. Hata yoksa bunu bastıracak. Hata şurada varsay yoksa zaten bunu bastıracak.
Hatayla alakası yok. Ben sadece bu fonksiyona ne girdiğini ve ne çıktığını görmek istiyorum. Tamam mı? Böyle printler yapabilirim değil mi?
Şeye girmiyor ki.
D'de üretiliyor buranın içerisinde bir yerlerde. Ne giydiğini bu basıyor. Çıkmadan önce D'yi return edecek yani bu.
Ne işe yarıyor yani? Otomatikman.
Doğru hesapladım mı ona bakmaya çalışıyorum.
Ha.
Yani çünkü ben bunu 10 defa çağırmışım. Her seferinde ne giydiğine ve ne çıktığına bakarsam, ya bunu yanlış hesaplıyor falan diyebilirim değil mi?
Ha.
Ama bunu her zaman görmek istemiyorum. Çünkü bu benim programım bunu yapmak istemiyor. Debug için bu. Dolayısıyla bu debug satırlarını açıp kapamanın yolu şu debug flag'i.
Okay.
Şey diyecektim, sen söyle istersen. Hocam benim yoklama şeyi nasıl olacak? Az önce anlatmıştım ya.
Sen kimsin? Burada 160 tane adam var.
Yok hocam az önce söyledim. Berkan Akın ismim şeydi. Listede yazılıydı ama değiştirilmiş.
Tamam dikkat et derse gelmeden önce bundan sonra. Bir bak oraya kim değiştirmiş baktın mı?
Hocam orada çok kişi var yani.
Nasıl çok kişi var?
Liste şey değil, şu satırı kim değiştirdi diye göstermiyor.
Gösteriyor. O hücreyi kim değiştirdi diye gösteriyor.
Ya da hocam telefonumdan baktım, buradan telefondan
İyi
gösterdi.
bak ona, desktop'tan bak. O arkadaşa söyledik ya bunun